Hello students, now we are discuss about some of the basic concepts in Python for data analytics, which is data wrangling, EDA and clustering. So I am with Tamilarasi, Assistant Professor in Department of Computer Science from Sri Shraddha College for Women. So what is EDA? Exploratory data analysis. It's one of the basic concepts in data wrangling. So who developed it? It's John Tukey from Princeton University in 1961. Bell Labs. So exploratory data analysis was Tukey's reaction to what he perceived as overemphasis on statistical hypothesis testing, also called conformity data analysis. So what is EDA? EDA is a bit different because it checks beyond the basic assumption about the data workability, which actually comprises the initial data analysis, that is abbreviated as IDA. So IDA provides complete observation or mock missing cases by appropriate features. So transform text or categorical variables, create new features based on domain knowledge of the data problem, have at hand a numeric data set where rows are observations and columns are variables. So simply EDA goes further than IDA. It's moved by a different attitude, that is going beyond the assumption. So what it follows like describe of your data. It's closely explore data distributions and understand how the relations between the variables present in the particular data set, and it also notice unusual or unexpected situations in the data and place the data into groups and notice unexpected patterns within the groups and take a note of group differences. Totally these are the basic features of exploratory data analysis. So, EDA is best described as an approach to find particularly patterns. So it used to find patterns and it spot anomalies or differences and other features that best summarize the main characteristics of a data set. So simply what is EDA? EDA is a exploratory data analysis, so which used to find patterns and differences and best features of the particular data set. So here we saw the difference between classical data analysis and exploratory data analysis. In classical data analysis, it mainly focused on the algorithms, analysis and conclusions, while in exploratory data analysis, here the data analysis part is preferable than data model algorithms. So here the problem identification start first, then based on problem identification data is going to be collected. The collected data will be analyzed. After the analysis, the particular suitable algorithm is going to be implemented. Then the model result can be provided as a conclusion. So it's the difference between data classical data analysis and exploratory data analysis. So EDA is a data focused approach. So EDA techniques makes almost no assumption and often make use of all available data. So we saw what is data wrangling and what is exploratory data analysis. What is data wrangling? Which is used to find important features of the data. To further, we need a exploratory data analysis. What is exploratory data analysis? Which is used to find important pattern of the data, any anomalies or differences present in the data, which also focused important and differentiate patterns or characteristics of the particular data. So next we go to the topic clustering. So what is the clustering? Cluster analysis or clustering is an unsupervised machine learning algorithm that groups unlabeled dataset. So it aims to form clusters or groups using the data points in a dataset in such a way that there is a high intra-cluster similarity and low cluster similarity. So in layman terms, clustering aims at forming subsets or groups within a dataset consisting of data points which are really similar to each other, and the groups or subsets or clusters forms can be significantly differentiated from each other. So what is simply it's termed as a cluster. So cluster creates group based on similar data points. It's called as cluster. So how it can be used? So what are the real life applications for clustering? The first one is customer segmentation. What is customer segmentation? Where it can be used? Maybe it can be used in banking customer segmentation. So what is the purpose? Here they used to extract the particular customer information from banking record, so which is called as a customer segmentation. Then classifying network traffic, the grouping together characteristic of the traffic sources. Traffic types can be easily classified using clusters. So we know every data moved on internet or intranet or Wi-Fi anywhere else, there is definitely a traffic can be present. So those traffic problem can be easily classified by using clusters. Then email spam filter. So the data is grouped looking at different sections and then can help classify which of them are spam. So we can easily, so simply it can collect similar data points in a group so that we can easily identify what is what. Then city planning, so grouping of houses according to the geolocation, value and then different type of clustering algorithms. So first one is a k-mean clustering. So what is k-mean clustering? We classify a given data set through a certain number of predetermined clusters or k clusters. So in k-mean clustering there is a predetermined clusters present, so which is called as a k-means clustering. The next one is hierarchical clustering. So hierarchical clustering follows two approaches, divisive and agglomerative. Agglomerative considers each observation as a single cluster, then grouping similar data points until fused into a single cluster, and divisive works just opposite to it. So which which is called as a hierarchical clustering. So it has two approaches, that is divisive and agglomerative. Then Fuzzy-Siemens clustering. The working of the Fuzzy-Siemens clustering algorithm is almost similar to the K-means clustering algorithm. So the major difference is that in FCM, a data point can be put into more than one cluster. So here note the point, the data point can be put into more than one cluster. So it can be present in more than one cluster. So this is Fuzzy-Siemens clustering. Then density based spatial clustering. So useful in the application areas where we require non-linear cluster structures purely based on density. So it's called as dense based spatial clustering. So what is clustering? Cluster is a collection of similar type of data in a group. So we have different types of clustering algorithms, that is K-means clustering, hierarchical clustering, Fuzzy-Siemens clustering, density based spatial clustering. So what is K-means clustering? So it's a certain number of predetermined clusters. Then hierarchical clustering follows two approaches, that is divisive and agglomerative. So agglomerative consider each observation as a single constraint, then grouping similar data points until fused into a cluster, while divisive work just opposite to agglomerative. Then Fuzzy-Siemens is working on the FCM algorithm. The major difference is the data point can be put into more than one cluster. So that is Fuzzy-Siemens clustering. Then density based spatial clustering, when we need non-linear cluster structure, it's purely based on density. So what is centroid based algorithm? The procedure for finding the centroid is straightforward. Guess a k number of cluster. So first guess a k number of cluster. The k centroids are picked randomly from your data points, are chosen so that they are placed in your data in very distant position from each other. All the other points are assigned to the nearest centroid based on the Euclidean distance. So form the initial clusters. Reiterate the clusters until you notice that your solution does not change anymore. So the iterative process of assigning cases to the most plausible centroid and then averaging the assigned ones to find a new centroid will slowly shift the centroid position toward the areas where most data points gravitate. So the result is that you end up with the two centroid position. So it is the basic working method of centroid based algorithm. So now you have clear understanding of what is k-mean clustering. The next one is the cross validation. So what are the steps involved in cross validation? First, divide your data into fold. So each fold is a container that hold an even distribution of the cases, usually 10, but fold size of 3, 5 and 20 are viable alternative options. So hold out one fold as a test set and use the other as the training set. So train and record the test set result. If you have little data, it is better to use a larger number of folds because the quantity of data and use of additional folds positively affect the quality of training. So perform steps 2 and 3 again and again using each fold in turn as a test set. So why is cross validation? So cross validation used to evaluate the performance of the model. How it can be done? We can divide the given data set into training and testing data set. Then the training and test data set can be iteratively processed for the cross validation. So the next one is a selection and optimization. So why it is need? What is the use of selection and optimization? We have a lot and lot of machine learning algorithms, deep learning algorithms. We have to select any one to to analyze a particular data set. For that, we need a selection and an optimization process. So whether the learning algorithm is the best one that can approximate the unknown function that you imagine behind the data you are using in order to make such a decision, you must consider the learning algorithm's formulation performance and the data at hand and compare it with other alternative formulations from other algorithms. So whether the specific formulation of the learning algorithm is too simple with respect to the hidden function to make an estimate. This is called a bias problem. So whether the specific formulation of the learning algorithm is too complex with respect to the hidden function to be guessed, so leading to the variation problem. So it's a very important concept, the bias and variance for the any selection algorithm. The choice of algorithm. So not every machine learning algorithm is good fit for every type of data, and choosing the right one for your data can make the difference. So how it can be done? So the selection of the right variables. The predictive performance is increasingly dramatically by feature creation. So new created variables are more predictive than old ones. And feature selection, removing redundancy and noise. So it is the role of selection. So what is the role of optimization? So machine learning algorithms perform function approximation, which is solved using function optimization. So what is function optimization? Function optimization is the reason why we minimize error, cost or loss when fitting a machine learning algorithm. Note this point, function optimization is the reason why we minimize error, cost or loss when fitting a machine learning algorithm. So optimization is also performed during data preparation, hyperparameter tuning and model selection in a predictive modeling project. So linear regression, logistic regression, neural network need the help of optimization. Now you have clear idea about what is selection and what is optimization. Selection used to select a particular algorithm for particular data type, while optimization focused selection of minimize the error, cost or loss when fitting a machine learning algorithm. Thank you. These are the references I made for this lecture. Now you have clear idea about what is data wrangling, what is EDA, what is clustering, then what is selection and optimization. Thank you for watching.